Bismillahirrahmanirrahim. Continuing the same topic. Most of the matter is made up of protons and neutrons in the nucleus, which are made up of quarks. Very interesting part is there is an antimatter. An antimatter, the same particles, the quarks are antiquarks and leptons are antileptons. One example is electron is a lepton, but a positron is a antilepton, it's an anti-electron. So matter and antimatter particles just combine together, they annihilate, turn it into an energy. Two of the quark types, up quark and down quark, they make proton and neutrons. The up quark and down quarks, they have fractional charge. The charge in the up quark is 2 upon 3, 2/3, and the charge on the down quark is minus 1/3. So that's now you can see that in a proton, there are actually two up quarks and one down quark. And if we add together, 2 upon 3 plus 2 upon 3 is 4 upon 3. Minus 1 upon 3 is 3 upon 3. So that is 1 plus 1. That's how proton is charged positive 1. Likewise, neutron, it's again made up of 3 quarks. But it's different from the proton. It has 2 down quarks and 1 up quark. Now if you add together 2 upon 3 minus 1 upon 3 minus 1 upon 3, answer will be 0. So neutron is neutral, it doesn't have any charge. Interesting. Mass is a totally different ball game here. Now look at the proton, its mass is 0.98938. But if we add individual masses of the quarks inside, that comes only 0.009 because 0.003 is of the each. Now 0.009 is less than 1%. So where is the other mass coming? This is a weird thing. In otherwise, particle at this scale, they behave totally weird, which has nothing to do with how our senses perceive at the particle, at the objects in the normal life. That's where Einstein's famous equation that energy mass are convertible comes handy to explain that most of the mass comes from the kinetic and potential energy of the quarks inside these protons or neutrons. These energies are converted into mass, which this equation describes well. And 95%, 99% of the mass is actually the energy which felt like a mass. The quarks, as we said, they are social particles. They always join together to form other particles, right? So not necessarily that they always join in 3 quarks. If they join in 3 quarks, this category we have classified, we call it baryons, like neutrons and protons, 3 quarks. But they join in 2 as well. So when they join 2, the examples are mesons, 1 up quark and 1 down, but you see a bar on the down bar, means it's an anti-down, antimatter, right? And likewise, it makes a pion, and anti-up and 1 down makes an antipion. So when the 2 of these join, this category is called mesons. And quarks have other types also, which is not called type, it's called flavors. There are very interesting vocabulary in the subparticle level. Even some of them were named like youth and love and that as well. But finally, this is the vocabulary which is now being used. Up quark and down quark, as we already saw. There is a strained quark and charm quark, and there is a top quark and the bottom quark. This top and bottom was the latest in the discoveries. The word quark actually came from the literature, from the James Joyce novel Finnegan's Wake. He used this just as a meaningless word, 3 quarks, and just it was picked from there. In 1964, Murray Glen-Mann and George Zweig actually suggested that. The names just came from these sort of not any specific that relations, but just for the sake of naming them. Like for example, the strange came from a strangely long lifetime of a particle, K particle, the first composite particle found to contain the quark. So it just got the noun strange from this. So that's a little bit of a history of quark, how it was named and all that. And it has 6 flavors. Quarks. The other particles are leptons. That's a category of particles. Electron is very famous. We are aware about electrons are leptons. All right. Likewise, the anti-electrons, which are positrons, are also leptons. Muons and tau are also leptons. They are charged like electrons, but their mass is much more. Electrons are very, very small mass as compared to neutron or proton, as we know. Neutrino is another type of leptons. Neutrinos has further 3 types, but these neutrinos have no electrical charge and their mass is extremely small, so little that electrinos, if they are coming on one side of the planet Earth, they just pass through the other side of the planet Earth without interacting with the matter at all. So this is totally weird. All particles are weird actually at this scale. That is so far our human beings understanding, and the journey goes on. What are we made up of? The answer is quarks and leptons, and quarks are of 6 different flavors, and leptons again are six types: electron, muon, tau, and 3 neutrinos. And how they interact together and what glues them are force carrier particles. Any force in the world is actually described by that category, which is called the bosons. We will discuss next. Thank you very much.